Hey guys, welcome back to AlgoYogi. We are doing two pointers series, and our next easy problem in the list is minimum difference between highest and lowest of k scores. It's the longest description or the title of the problem I've seen so far. Okay, so you are given a zero indexed integer array nums where nums I represents the score of ith student. So you are also given the integer k. Now pick the score of any k students. So any k students from the given nums of the array nums, so that the difference between the highest and lowest of the k scores is minimized. Okay, so return the minimum possible difference. So basically, given an array where ith index is the score of ith student. Now there is another integer k, and I'm hoping k should be lesser than the length of the array, because we got to select k students from this array, so that we are basically taking the highest and lowest of the selected k students, and then trying to minimize from these students that we have chosen, basically trying to minimize the lowest, basically the difference of this highest and lowest score. Okay, and that you can do basically with all the subsets or sets of this array, the students, the k students you can select from this nums array. So seeing the first example, nums is given ninth basically of length 1, and the score is 90 of ith student, I equals to 0. K is given 1. Now highest, what can you choose? Like, you have to choose one student from array whose length is 1, and then you got to find the highest and lowest score. So highest is 90 and lowest is 90. So basically the minimum diff is 0. That's it. That would be the answer for example 1. How about example 2? Here k is 2 and the length of nums is basically 4. Now you can basically select different k students from here. So let's say we can basically make combinations of 9 and 4, 9 and 1, 9 and 7, 4 and 1, and so on. But honestly, since we really want to find out the minimum difference, how about we sort the array and we create this window of size k, and we keep moving it towards this in this sorted array, and then only basically update our result, which is minimum difference between highest and lowest score, with the window that we're moving, and just take the end of this window, because once it's sorted, then the lowest would be in the front and the highest would be in the end of this window that we are moving. So what I mean to say, let me just show you over here, is this. If I sort my array, this one, and remember k is equal to 2. If I sort it, what's going to happen to values is it will become like this, sorted value. Now I will take my left pointer and right pointer. So this is the window that I'm creating. This is window of size k. This is another window of size k, another window of size k, right? This is another window of size k. Here, what's really happening is I don't have to compare, I don't have to choose these two. Why do I want to choose? These will be basically giving me the maximum difference of two students, right? So I don't want to take these. I want to take the closest values, right? And that too in the sorted array, right? That too in the sorted array. So here the difference would be 4 minus 3, 3. So 4 minus 1, 3. 7 minus 4 would be basically giving you 3 again, and then 9 minus 7 would give you 2, and that is what our answer should be for our example 2. So this will return answer 2 for this example. Okay, so we sort the array, we create this window, we have 2 pointers, beginning and end. Keep moving the left pointer, basically both pointers, and just keep comparing with your result array if you need to update it, right? And initially set it to like infinity, since you just want to reduce that value down to the minimum value. It's gonna be easy peasy implementation, big of and time complexity. Let's get it. So first thing first, nums.sort, we sort the array. Then we have our start and end, which will be 0, and end would be basically k, but let's do 1 minus k because we are accessing the indexes here. Okay, so start and end. Now we start our while loop until, I think this time, you know what, let's check our end is lesser than nums.length. Okay, len nums. While this satisfies the condition, then we can keep incrementing this window that we created, you know. Okay, now what's gonna happen is we will have our result array. I forgot to have that, and let's have it as float infinity, and that's how you create an infinity value. So here let's calculate the difference, let's update it. Rest would be basically minimum of result or nums end minus nums start. Okay, this is because end would be the bigger value. We always want to have a positive value, right? We could create it like the, you know, we could have the absolute, but not necessary at all, since we know in the sorted array the next value will either be equal or greater. Equal would give us 0, and there is no chance of getting negative value here. And we basically start our pointer by 1, and we also increment our end pointer by 1. I should have named them left and right, but still this works. Okay, and then finally we just return our result. All right, I do not see any scope of any mistake here. Let's zoom out and run it on examples. Awesome. Submitting the answer, and let's get ready to write down our time complexity. That is because of sorting of the array. I couldn't think of any other solution. Otherwise, it would be just creating all these combination permutations of size k from our nums, and then again sorting them, and like trying to find the minimum and the maximum of these windows, right? I think this is the easiest. You don't want to have those windows and then you know, these permutations, and then again find highest and smallest and then update our answer. That would be just too much. So big of n log n, and space again. If you're playing around with pointers, dude, you don't need that much space. You just need it constant space to store your answer, and that's what it is. Big of 1. Let's go to AlgoYogi, mark this problem solved, and see you guys in the next problem. Until then, bye bye.